Let's practice approximating some irrational values together. For each of these given expressions, we're going to go ahead and figure out which two consecutive integers each of these expressions is going to fall between, and we're going to write our statement using inequality, so using less than and greater than. For number 1, we have 80/7, so we can go ahead and take this 80 and divide by 7 to see where this is going to lie between. 7 fits into 8 one time 7 is 7. 8 minus 7 is going to be 1, so we have 10 remainder. This goes in once, 1 times 7 is 7, 10 minus 7 is 3. So we know this is going to be 11 3/7. So where is this going to fall between? Well, I think the two integers that we can say this falls between is going to be 11 and 12. So 11 is going to be on the smaller side. That's going to be less than the 80/7 that we had initially. And this is going to be less than 12, right? So these are the two integers that the original expression or value was sandwiched in between. For number 2, we have 56/3. So let's go ahead and do the same thing here. So 3 goes into 56, goes into 5 one times. 1 times 3 is 3. 5 minus 3 is 2. Bring the 6 down. 3 into the 26 8 times. 8 times 3 is 24. 26 minus 24 is going to be 2. So this is equivalent to 18 2/3. Okay, so I think we know this is going to be between 18 and 19. So on the smaller integer, we have 18. That's going to be less than this 18 2/3. And then this is going to be less than 19, which is the integer that's greater than it. Next, for number 3, it looks like we have a decimal that's being squared. We have 4.5 squared. So that's just going to be 4.5 multiplied by 4.5. Okay, so let's see what this is going to be. So 5 times 5 is 25, carry the 2. 5 times 4 is 20 plus 2, that's 22. 4 times 5 is 20, put the 0, carry the 2. 4 times 4 is 16 plus 2, that's going to be 18. So adding these two rows up together, we have a 2, a 5, that's 10, carry the 1, that's 2. Decimal is going to be over here, so this is going to be 20.25. So the two integers we're going to say this is between is going to be 20, that's on the small side. That's going to be less than 20.25, and that's going to be less than 21. So the value of this falls between 20 and 21. For number 4, we have 7 2/3 squared. We need to make sure we write this as an improper fraction. So this is going to be 7 times 3 is 21. 21 plus 2 is 23. So we really have 23/3, and we're squaring that, so we're multiplying it by another 23/3. Now 23 times 23 is going to be 529, so we're going to have 529 over, and 3 times 3 is going to be 9. Okay, so we have 529/9. If we go ahead and rewrite this as a mixed number, we have 529. We're going to divide that by 9. Let's see, 9 goes into 52 5 times. 5 times 9 is 45. Looks like the remainder here is going to be 7. Let's bring that 9 down. So 9 into 79 8 times. 8 times 9 is 72. We have a remainder of 7. So this is going to be equivalent to 58 7/9. So this is going to be between 58 and 59. So 58 is going to be on the smaller side. That's the integer that is directly smaller than it. And the integer that's directly bigger than it by 1 is going to be 59. So this value falls between 58 and 59. Alrighty, for number 5, we have the square root of 52. Now we want to figure out the square root of 52 is sandwiched between which two perfect squares. Well, let's see. We know that a perfect square that is going to be less than 52 is going to be 49. That's going to be less than what we're looking for here. And then we have the square root of 52. So I'm going to go ahead and put 52 right in the middle. And this has to be less than what? So 7 times 7 is 49, but 8 times 8 is 64. So this would be the square root of 64. So the square root of 49 is going to be 7. So 7 is smaller than the square root of 52, which has to be smaller than 8 because the square root of 64 is 8. So we know that the square root of 52 has to be between 7 and 8. For number 6, we have the square root of 230. Now you want to memorize some of your perfect squares, or you can go ahead and just multiply them out too. But the perfect square that is below 230, I believe, is going to be 225. That is going to be a perfect square that's a little smaller. And we have the square root of 230. That's the given value we have here, or expression. And so I know 15 times 15, 16 times 16, that's going to be 256. So this is going to be the square root of 256. Now the square root of 225 is going to be 15. 15 is going to be smaller than the square root of 230. Okay. And that one's going to be smaller than the square root of 256 is 16. So we know the value, the square root of 230 is between 15 and 16. Here's number 7. For number 7, we have 5 times the square root of 6 plus 9 times the square root of 6. Since we're adding two terms that both have that square root of 6, we can say 5 plus 9 is going to be 14. So this is going to be 14 times the square root of 6. Now the square root of 6 you can go ahead and put into a calculator. You're going to find out that that's going to be roughly, I think, 2.45. And actually, let's go ahead and change that equal sign to an approximation instead, since we are rounding at this point. Okay, and so we have 14 times 2.45. I'm not going to write out the multiplication for that, but this should be about 34.3. So keep in mind that we can add these two pieces together because they both have that square root of 6. So where is this between? Well, this is going to be between 34. That's going to be less than that 14 root 6, or we can say the original was what, 5 root 6 plus 9 root 6, which is right the original there, and that's going to be less than 35. So we know this value is going to be between 34 and 35. For number 8, we have 7 root 24 minus 2 root 24, and since they both have the same radical, we can say 7 minus 2, and that's going to be 5 times the square root of 24. Now the square root of 24, that should be a little bit less than 5, so you can either plug that into a calculator or play around with that. I think it's going to be maybe around 4.9 or so. Now plugging that into a calculator, it is roughly 4.9, so hopefully that makes sense because 5 times 5 is 25, and 24 is just a little bit less than that. And if we go ahead and multiply 5 times this 4.9, we're going to get about 24.5. That being said, on the small side, the integer that this is going to be greater than is going to be 24. 24 is going to be smaller than the 7 root 24 minus the 2 root 24, and this is going to be less than 25. So we know the value of this expression is going to be between 24 and 25. For number 9, we have e. So if you aren't sure what this is, in math, this is just maybe something new to you. This is going to be about 2.71828, and it's actually 1828 again, and it goes on forever and ever and ever, so it's just like pi. So it's a pretty interesting number, and if you've never seen it before, now hopefully you just know the rough value of it. And so it's just between 2 and 3, so 2 is going to be what this number is on the small side. I'm going to put e right in the middle here, and e is going to be always less than 3 no matter what. So e is sandwiched between 2 and 3, a little closer to 3, but those are the two integers it lays between. Okay. For number 10, we have pi. Hopefully you've seen this one, or if at least heard of this one, a little bit more common. So pi is about 3.1415, and it goes on forever with no specific pattern. And so we have 3 on the small side. That's going to be less than this pi, and pi is always going to be less than 4. Okay, so pi is going to be between the two integers of 3 and 4. For number 11, we have e squared. So again, e is roughly what's about 2.718, so on and so forth, and we're going to multiply that by itself. So if you go ahead and just multiply this out, 2.718 times 2.718 roughly, so that's just something you're going to need to know. That's going to be roughly 7.39. So this is going to lie between 7 and 8, right? So those are the two integers. So 7 would be less than whatever this e squared is going to be, and that's going to be less than 8. So e squared falls between 7 and 8. And one last problem dealing with some more irrational values here. So this time we don't have e, but we have pi. So pi, again, the first few digits are 3.14. I'm just going to write 3.14 for now. Let's go ahead and square that. We should get a pretty good estimate there. Now multiplying 3.14 by 3.14, that's going to be approximately 9.87, somewhere around there. So squaring pi, we get approximately 9.87. So on the smaller side, we're going to say that's going to be 9. That's going to be less than whatever pi squared is. And pi squared is always going to be less than 10 though. So even though it goes on forever for a decimal, it is still less than 10, but greater than 9. So there you have 12 different problems dealing with some rational values and some irrational values, where we're trying to figure out if we're going to get some values between some specific integers. So if you found the video helpful in understanding just a little bit better how to approximate some of these, or just get your head wrapped around some of these irrational values, hopefully you found it helpful. As always, keep up the great work that you're already doing, and I'll see you in the next one.